It's Santa's job every year to deliver millions of presents around the world. But he can't be everywhere at once. Or can he?
That doesn't make sense.
You may be interested to find out that Santa has some engineering tricks up his sleeve in order to accomplish this task. After an investigation into Santa's activities, we've discovered many interesting space engineering technologies that Santa is utilizing in order to achieve this impossible feat. During our extensive research into Santa's secret facilities, we've also discovered why Santa favors the North Pole for his holiday operations. It turns out that Santa has a secret. He's actually a space engineer. I mean, it kind of makes sense. Santa's up there jetting around all night in his fancy sleigh powered by reindeer. Not exactly amateur stuff, but it turns out that Santa may be going higher than any of us expected. As a space engineer, Santa knows that he can access all areas of the world by utilizing the properties of a special type of orbit called a polar orbit. Usually orbits go around the center of the planet, which means they only pass over the equatorial regions of the world. However, from a polar orbit, the orbital track moves north to south, and this means that the rotation of the Earth causes the ground track to move sideways by about 23 degrees on each orbit of the Earth. In this sense, Santa can pass by quite closely to nearly all locations on Earth in just one night. This is certainly more than enough in order for Santa to meet his Christmas schedule. And it turns out that Santa's North Pole facility is actually ideally located in order to get into this type of orbit.
Very interesting.
So now that Santa is in orbit, how does he manage to get all those gifts into all those homes? Well, after some extensive laboratory research into the composition and materials used in Christmas gift wrapping paper, we have made some shocking discoveries. In order to survive atmospheric re-entry, which Santa's gifts would need to do in order to get out of orbit, you need a material which doesn't absorb very much heat energy and also reflects away any heat energy that's coming towards it. Things that re-enter from orbit get really, really hot, like 2,000 to 3,000 degrees hot.
That's a spicy meatball!
Well, it turns out that Christmas gift wrapping paper has the ideal properties in order to shield the spacecraft from the heat of the bow shock. Christmas wrapping paper is shiny, which means that it's able to reflect away a lot of the energy that comes from the bow shock. Also, the wrapping paper is made out of paper, which means that it has great thermal insulative properties.
Coincidence? I think not!
Essentially, Santa is wrapping all those presents not just for the pretty pictures, but also in order to keep those presents from getting toasty on the way back from orbit. In addition to the wrapping of presents, we've also done some extensive research into the geometry of the gifts themselves. The shape of most presents can be described as a blunt body. This essentially means that it's not very aerodynamic. At first, this may seem like a bad idea for a gift delivery mechanism that goes through the air. After all, won't that make the presents fly worse? It turns out that a blunt body is actually the best shape to push back the bow shock and reduce the amount of heating that the vehicle will experience as it's coming in for the re-entry. Given all the variables, we can clearly see that Santa's gift wrapping operations are mainly focused towards making sure the presents are delivered safely. Christmas gifts specifically wrapped in Christmas gift wrapping paper re-enter from a polar orbit and are precision targeted towards all the homes all throughout the world. We're on to you, Santa. Your mastery of space engineering can't fool us. But you may ask, how does Santa get all those gifts into orbit in the first place? I mean, there are nearly 1 billion children in the world, so it seems like the math on that is not going to quite add up. If we assume each gift is, let's say, 250 grams, then that would mean there's 250 million kilograms of presents being delivered worldwide in just one night. Even if we consider that 20% of the children are naughty and not getting a present this Christmas, that's still 200 million kilograms of presents. Surely that's too much for anyone to get into orbit. But this is where Santa's greatest trick comes to play. It is clear to us that Santa's education in space engineering has a heavy focus in propulsion, because Santa has developed the most advanced propulsion technology ever known to man, the reindeer drive. In order to describe how effective an engine is, space engineers usually use the term of specific impulse. This is essentially describing how efficient the engine is at providing thrust for the rocket. And it turns out there's a special equation that we can use in order to determine just how efficient Santa's reindeer drive really is. It's called the rocket equation. All we need to do is populate the necessary variables into this equation, and then boom, that'll tell us once and for all just how advanced Santa's alleged technology really is. The delta V that we need in order to reach a polar orbit is about 9,000 meters per second. So this is what we're going to put in for the delta V variable. For the initial mass of Santa's sleigh, we need to combine a couple of different factors that will describe how heavy Santa's sleigh really is. The first most obvious part are the presents themselves. And as we already calculated, there's going to be about 200 million kilograms of presents. We also need to consider the mass of the sleigh itself. As far as we can tell, based on current technology, it's not really possible to build a container that is much more efficient than 1% the mass of the things that it contains. To give you an example, if you have a Coke can, the mass of the can itself is roughly 3% of the mass of the whole system itself. So we're going to be generous for Santa and say he's actually got some really advanced technologies going into his sleigh, and we'll say that the sleigh is about 1% the mass of the presents. About 2 million kilograms. That's one big sleigh. Finally, we need to consider the mass of the jolly man himself, and also his reindeer. Looking at online sources, we discovered that the mass of a fully grown reindeer is about 200 kilograms. So for the 9 reindeer that make up Santa's entourage, that's an extra 1,800 kilograms of mass. If we count Santa as well, let's round that number off to 2,000. But we're not quite done with this number yet, because we also need to consider all the food that Santa has to feed his reindeer in order to energize them to pull his sleigh all the way into orbit. And after some extensive research, we've discovered that Santa takes along about 1,000 kilograms of candy corn and candy cane in order to power his reindeer drive.
We elves try to stick to the 4 main food groups: candy, candy cane, candy corns, and syrup.
Adding this to our initial mass, we get an initial mass of the sleigh being 202,003,000 kilograms. The next parameter in the rocket equation to consider is the final mass of Santa's sleigh. And that's the mass of the sleigh without all of the food aboard, once we've finally arrived in orbit. So essentially all we have to do is subtract the 1,000 kilograms of candy corn and candy cane, and we should be at our answer for this variable. In the end, it's about 202,002,000 kilograms. The final variable in the equation is g, and this is just the gravitational acceleration of the Earth, which is 9.81 meters per second squared. So now we have all our variables for the rocket equation. We can just solve for our specific impulse. And just plugging in these values, we get an incredible 185,326,000 seconds. Putting that into perspective, the most efficient engine that we know of is the ion drive, and that only has a specific impulse of about 10,000 seconds. You can find out more about those types of engines in the video that we last did. It'll be in the card above. Basically, this means that Santa's reindeer are 10,000 times more efficient than any propulsion that we know today. So clearly Santa's onto something.
You know nothing, Jon Snow.
Let's take a look at where Santa's reindeer drive would fit on the chart that we used last video to determine the efficiency of rocket engines. The specific impulse and thrust of Santa's sleigh would actually put it somewhere more on the order of an antimatter drive. So maybe the candy corn and candy cane that he's feeding to them is actually made out of antimatter. This could explain the insane efficiency that he's getting. Of course, one day we hope that Santa will share his amazing technologies with the rest of the world, because the efficiency of his engine would certainly revolutionize the space industry today. There are many other unexplained questions about Santa's activities through the Christmas holidays, and we will continue to do our research into discovering everything there is to know about Santa's miraculous achievements. If there's a question about Santa's operation that you have, be sure to put them down in the comments. To support ASTRA in starting to develop technology that may one day be as good as Santa's reindeer drive, be sure to give this video a like and subscribe. And remember to keep expanding your horizons.